So we have a function f of n that is equal to n square. Again, we have a function that is called as g of n. We have a value n. Now see here, what we have to prove here, very simple. So basically we know the definition. So whatever the f of n is equal to g of n, big O of g of n, we have to prove it. So that's why what I will do, I will do n square that is equal to big O of n. We have to prove this. That is what exactly our idea. Now then, so this is our idea. Now what I will going to do, see everybody observe here. So basically n square, right? So when you if you want to prove this, what is required? Constant is required. Correct? Huh? Yes or not? Constant is required. Clear? Anwar understood, Anwar? Anwar. Chetan. Chetan got it. Chetan.
Yes, sir. Got it, sir.
Okay. See, if you want to prove this one, please understand here, everyone. I wanted to prove this. Okay, thank you. So I wanted to prove this. So that's why what I wanted, I need a constant. That's the reason I told you already, n square, okay, less than or equal to c dot n. Okay, for all, please understand, for all, nothing but one, for all, for n values, okay, n should be greater than or equal to constant n naught. This one, please understand these lines. Okay, n square is less than or equal to, okay, c dot n, nothing but c of n. Okay, for all n values, n should be greater than to n naught. This is what exactly we have to prove. Here I will going to tell you one more important thing. C is nothing but what? Constant. Suppose 10 is a constant, 20 is a constant, everything is constant, right? I cannot take function as a constant here because function varies. Yes or not? I cannot take n as a value here. Please, that is a function. Function cannot be constant here. Okay, you cannot take the function here. Please understand. That is the reason why. Here example n dot n, nothing but what is the value you will going to get it? N square. Howdalva? See, if I do n dot n, you will going to get the n square less than or equal to, please here what is there? C, observe here, c dot n, that is also okay. N is also function, n is also function. This completely belongs to one function. Here also same thing, c dot n. So but you cannot take c value as a n value, so that is dangerous. You should not take that one. How to prove this one? What I wanted to prove, I wanted to prove this one, big O. Is it possible to prove? Let's see this one. Basically I will go here, take n square, okay, n square less than or equal to constant of n. Okay, now what I wanted to prove, I wanted to prove this area is bigger. That's it, nothing else. Okay, I wanted to prove this one, g of n is bigger, right? So big O of n, we have to prove it. Nothing but what? Big O of g of n is bigger, like that we have to prove it. So that is the reason why what I will going to do, I will going to take n value is equal to 10. Please understand here, I will going to take n value is equal to 10. What happens here? 10 into 10. What is the value we're going to get it? 100. Here c dot 10 square. Okay, c dot 10 square. Suppose example, assume here c value I will going to take 100. C value I will going to take 100. This is 10 into 10, 100. I will going to get it again less than or equal to, okay. So here you can able to see, please understand everybody, here you can able to see when I do 100 into 10, what is the value you will going to get it? 1000 or not? 1000 or not? Tell me, 1000 or not, guys? Correct, huh? Guys,
Yes,
got it?
sir.
Yeah, 1000
Sir.
we will going to get it. Now we are able to prove this is greater, but for every n values, is it possible? Please check it that one. For one value, okay. What I'm saying, see the definition here, please, everybody. For all n values, n should be greater than or equal to constant n naught. We have to prove this one. Already I told you, such that there exists two constants. Okay, there exists two positive constant. Already I mentioned that one, but this one we have to satisfy. Suppose if you go, that is what exactly I'm talking about here. If it is 1000, n value, okay, if it is 1000, take it 1000, okay, less than or equal to, please understand here, okay. So for example 1000, here what happens, this one also will become 1000, yes or not? This one, so that time also that is okay. For example, one more value I will going to take it here. What is that? 1000 square, you take it 1000 square. n value is equal to n value is equal to 1000. Okay, when you take n value is equal to 1000, what it will become? 1000 square it will become. After that, less than or equal to what I take an n value 100 into, please check this one, 100 into 1000. Where it will go? It will go somewhere. Yes or not? Lakh something. Again you check it for lakh. Okay, for lakh you check it. Lakh square. Here you check it. Okay, 100 into, okay, 1 lakh. Now you tell me which is greater here. So this is not a greater one. This is the greater one, right? Guys, getting what I'm saying is getting everyone?
Yes, sir.
Now, according to the definition, please understand. According to the definition, what it says that for every when value, please this line I'm talking about. For every when value, we should prove this one as a greater. This one we have to prove it. But what it is saying here, it is not saying this is greater compared to this one. So that is the one reason. That is one reason. Okay. So what happens here? You cannot say that n square is okay big O of n like that. N square is equal to big O of n. You cannot say this one. That is the reason why we cannot able to prove. Everywhere we cannot able to write big O. Understanding? Everywhere we cannot able to write big O. That is the problem. Okay, for every n value, it will not going to satisfy. So in this area, you can able to see for every n value, is it satisfying? No, not at all satisfying. Some part of time or some mode of time, what is this? This value will become greater compared to this one. Nothing but what we have to prove. We have to prove this is greater. But is it possible for all n values? No, not at all possible. That's why you cannot write like this. Okay, this is a drawback here. Not a drawback. What I'm saying is exactly you cannot write for big O for every function. Okay, we cannot write big O for every function. There are certain values. Okay, so we have to identify that, we have to prove it. So again, go back again, one more thing. Okay, if you are able to understand this, that one means just go for this one. I am writing the definition for omega. Definition for omega. I will tell you what is that exactly. Okay, so for that, if you want to prove that one, I'm telling you, if you want to prove that one, take C as a constant over there. Okay, C value is equal to 1, definitely we're going to get it. But later I will do, right now not required, right now not required. Okay, just take omega definition here. What is this omega definition? Is nothing but, see here, everybody observe here. Suppose here I will going to say f of n, if f of n, okay, is equal to omega of g of n. Okay, this is what exactly we have to prove it. Yes or not? When function f of n is equal to omega of g of n, this is what exactly I wanted to prove it. There, when you go to the big O, without constant, is it possible to prove? No, not at all possible. That's why constant will going to say, okay, I will going to take care of all these things. Whether if you want to prove means, I will going to take care like that. It will say here when it's come here, what we are doing, f of n is equal to big O of n if f of n, function f of n greater than or equal to constant, okay, constant g of n, okay, for all n values. That's what exactly I'm talking. Okay, for all n values, n should be greater than or equal to n naught. This is very, very important time. Please understand. Such that, see here, such that there exists a pair of, please understand, a pair of, okay, c and n naught, these are all constant, where c should be greater than 0, already explained, and n should be greater than or equal to n naught. This is the definition, please. Okay, this is the definition. For this one, I will going to write a program. See here, what exactly we are doing here. Please observe everyone. What exactly we are doing. I wanted to prove this. What is that? F of n is equal to omega of g of n. I wanted to prove it. To prove this one, please here, we need this. Okay, understanding everyone? To prove that one, to prove this, we need this. Okay, that is the reason why f of n greater than or equal to nothing but this is a smaller one. F of n is greater than or equal to c constant g of n, nothing but this is smaller. We have to talk right side only, smaller to this function. Okay, c of g of n is smaller to f of n, we have to say like that. Okay, so here also same thing, for all n values we have to check it again. N should be greater than or equal to n naught, nothing but this is also constant. Again you can able to see this is also constant. Let's take one problem. Shall I take one problem, guys? Shall I take one problem now? Problem number one, example one. Same problem I am taking, don't worry. So what I am taking, same problem, whatever the problems we have done there. So same problem I am taking, that only we will do. F of n, please here, there is a function f of n that is equal to n plus 1, n plus 10. Again g of n that is equal to n. Okay, now see here, what we have to prove, f of n that is equal to omega of g of n. This is what we have to prove. How to prove, sir? Very simple. How to prove this one? Very simple. Using constant. Please understand. Using constant, we can able to prove it. Using someone's help, I can able to prove it. Whether it is greater or smaller, we can able to prove it. For that, what I will going to do? N plus 10. F of n is what? N plus 10. Okay. Greater than or equal to c dot n. Correct? See here, where I have taken n plus 10 because from here. From here. Where? Here. F of n, this is n plus 10. Again g of n, where I taken, from where I taken, this is n value, here. Okay, this is a constant one. For all, check for all n values. For all n values you have to check it. Again, n should be greater than or equal to n not constant. So for that, what I will going to do, take, now you people please understand, now take everybody, take c value is equal to 1. Okay, again n value is equal to 1. Check it now. So if I take n value is equal to 1 plus 10, what is the value we're going to get it? 11. Correct? Again greater than or equal to c value. What is the values we have? C value 1. 1 dot. N is what here? 1. 1 into 1, what you will going to get it? 1 only. Yes or not? Now you tell me 11 is greater than or equal to 1. Nothing but for 1 itself we are having a value. Yes or not? It is holding the value or not? Please you tell me now. For n itself, for n is equal to 1 itself, it is a holding the value. So that is the reason why whatever the constant value, it will going to change. Whether you wanted to prove bigger or smaller, constant will going to help you. Clear? Everybody clear? Please let me know if you are clear. Understanding now? I taken this value, c is equal to 1 and n value is equal to 2. So now you check. So when I substitute all this value, automatically you are getting this value is equal to 12. 12 again greater than or equal to 2. Nothing but what? Again you can able to see. Nothing but what? This satisfies. This satisfies. Okay. N naught is what? N naught is what here? Please understand. N naught is 1 starting from 1. Starting from 1. Okay. So take 2, 3, 4, 5. Every value satisfies. Every value satisfies. Nothing but who is the constant here? C is equal to 1 is the constant. Again, n naught that is equal to 1. These are all the constants. Okay. These are all the constants. There exist two constants. Understood? Everybody clear? Hello. Some people, okay. Some people will want to ask, sir, okay, sir, you taken 1. Can I take C value is equal to 1 by 2? Right now, it is not required. You can take it. Please understand, you can take it, but it is not at all required. Okay, not at all required right now. Because already these values are increasing. Why you wanted to go for n by 2? Not required. Okay. It will become so less. Not required right now. Okay, no need, no need, no need. Please understand this. Okay, let's take one more problem. Let's take one more problem, guys. Guys, you got that? You got it? What do you mean by omega now? Okay, understood or not? Hello, everyone. Please let me know. One more. See, f of n, I will going to take f of n. This is function. Please understand, guys. F of n is a function having a value n square plus n plus 10. Okay, na? So this is one. Again, g of n we have, that is equal to n square here. Okay, now see what we have to prove. Please understand what we have to prove. We know that very clearly. Okay, n square plus n plus 10, that is equal to omega of, okay, n square. This is what we have to prove. That is what f of n equal to omega of g of n. This is what exactly same thing. Now please understand here, everybody. I think up to here, okay, everyone, okay. Now, what is the c value we have to take it? That is the biggest thing. So before taking all those things, let me write this one: n square plus n plus 10 greater than or equal to, see this symbol, which one we have to prove? Right side, left side I have to prove greater. Please understand, left side I have to prove greater, right side I have to prove lesser. Smaller we have to prove. So that is the reason why c dot n square, okay, for all n values, n should be greater than constant n naught. Clear? All n values must be satisfied. That is what, whether your algorithm will going to take input or not, but it has to give the one output. So that is the reason why constant will going to make a difference here. Understanding? Constant will going to make a difference. So right now you tell me which is greater in this, which is greater. Okay, it's okay, no problem. I will going to take it, no problem. Okay, I think everybody understood this one. Now what I will going to do, take c value. Please everybody observe here. Take c value. C value is equal to 1. Okay, na? Again n naught. Okay, take this value is equal to 1. Okay, now please check everybody, what is the value you will going to get it. Suppose if I take n value is equal to 1 here, 1 square plus 1 plus 10 greater than or equal to, c value what, 1 dot, n value is what right now, 1 square. Okay, now what is the value you're going to get it? 1 plus 10, nothing but 10, 12. Okay, 12 is greater than or equal to 1 into 1 square, that is totally 1 only. Now we proved or not? You tell me, now we proved or not, guys? Now we proved or not? You message me, yes or not?
Yes, sir.
Yeah, that is what exactly. If you take n value is equal to 2, again same thing, 2 square 4. Again here what happens here, 1 into 2 square, it will become 4, but here 10 plus again 4 14 16 it will come. 16 is greater than or equal to 4, you will going to get the value when you take n value is equal to 2. Yes or not? Still this value is proved, that saying that left side value is greater than right side value. What is the constants here? C is equal to 1. From this value, from this value it will going to hold the values. So that is the reason why n naught is equal to 1 here. From n naught, okay, you can able to see, you take any values. Now 1 is there, if I started with the 1, n naught is 1 should be greater than, go for 2 3 4 5 6, whatever the values you will going to give, every value will going to satisfy, nothing but every value satisfy right side greater, sorry, left side greater, I'm sorry, left side greater, it will going to satisfy. That is the reason why for all n, for every n it will going to satisfy. So that's why finally I will going to say, what is that, n square plus n plus 10 is equal to big O of n square. Okay na, sorry, omega of n square. Clear? Everybody understood this one? Please, got it or not? This one, everybody got it or not? Guys, got it? Hello? One more. If you are not able to understand, please watch the recording video. You will get it. Okay. No need to worry. No need to take tension. Slowly, you will learn everything. Everything I will teach you. Don't worry. Everything I will teach you. Next page. Okay, fine. Here, you take it. Okay. One more program. F of n, that is equal to n minus 10. Okay, again same problems I am taking, those problems I am converting into, otherwise you will not going to understand. That's why g of n, that is equal to n plus 10. Okay na, same problem. What we have to prove? Very simple. N minus 10 is equal to omega of, what is that, n plus 10. This is what we have to prove it. How to prove this one? Very simple. So n minus 10 less than or equal to c dot n plus 10 for all n. Yes or not? For all n, okay, n should be greater than or equal to n naught. This is what exactly we have to prove it here. Here also same thing. Let's take c value is equal to 1. Again, n naught value is equal to 1. Or if you want it, you start from any value. Okay, 1, 2, 3, like that you start it, you will going to get it. But what I will going to do, I will going to take n naught value is equal to 10. Before that, what I will going to do, I will going to take the value n naught is equal to 1. Let's nothing but what n value is equal to 1 here. Just I will going to check n value is equal to 1. Let me check. So 1 minus 10. Okay, sorry, I made a mistake here, please pardon me. Small mistake here. I forgot on this. Wait, here guys, just I will, okay, here, this one is the problem. Okay, that's it, nothing else. Greater than or equal to. Okay, fine. Now see here everyone, observe here. So what we have to prove here, 1 minus 10 is greater than or equal to c dot, okay, n plus 10. This is what exactly we have to prove it. Yes or not? Now very simple, how to prove this one? This is very simple, how to prove this one? That is the reason why I have taken the values. First you check with the n value. So 1 minus 10, what you will going to get it? Minus 9, greater than or equal to. So here c value I am taking 1 dot. Okay, what is the n value? 1 plus 10. Is it possible? Is it possible? See here, minus 9 greater than or equal to 1 plus 10. Okay, it will become 11. 11 into 1, it will become what? 11 only. Now minus 9 is not greater than or equal to 11, nothing but it will not going to work. That is the reason why you check for n value is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, like that you have to check it. So we know that very clearly at this point. Take it n value is equal to 10. Now you check it. What you will going to get it? So now just I will going to overwrite on this 10 value. N value is equal to 10. 10 minus 10. What you will going to get it? You will going to get the value 0. Yes or not? Now C value is equal to 1. Here also you can able to take. What is that? 10 10 plus 10, what is the, you will going to get it? That is 20. Now also you check it. What is the value? 0 greater than or equal to 20. Now also it will not going to prove. Yes or not guys? Now also it will not going to prove. Will it going to prove or not? No, not at all. Again take n not n value is equal to 20. Check it. Okay, here see here. Here see again, you people see here. Here what happens here? It will become 20. 20 minus, please understand, 20, right? 20 minus 10 greater than or equal to, again here also c value currently 1. Okay, 1 dot 20, n value is equal to 20 plus 10. What is the value? You will going to get it? 30. Okay, here 30, again 20 minus 10, you will going to get 10. Always it is going greater. When should I prove this one? When should I prove this one is a greater? So that is, it's very difficult. So that is the reason why what we are doing here, please understand. Why my eraser is not working? My eraser is not working. Fine. Understand? Everybody getting? Every time right side we are getting greater. That is the reason why this C constant is not at all changing this one. Please understand. This C constant is not at all changing this one. That is the reason why what I will going to do. Please understand here. What I will going to do, I will change this C constant to fraction 1 by 2. Understanding everyone? I will going to change this C value is equal to 1 by 2. Now apply. Okay, everybody now apply. So definitely you will going to get it. Suppose for this one I will going to apply. Just observe here. So what I will going to do, I will take n value is equal to 10. Okay, you check for 10. Okay, what we will going to get it? Basically we got it here. 10 minus 10, 0. Again 1 by 2. What you will going to get it? 20. 20 divided by 2, 10. Again also greater. Take n value is equal to 20. Still you will not going to get it. Now take n value is equal to 30. Again C value is equal to 1 by 2. I told you C value you have to take right now 1 by 2. Now we check. Okay, what is the n value right now? 30. 30 minus 10 greater than or equal to c value what? 1 by 2. Okay, now 30, n value is 30, yes or not, plus 10. Please observe this line. Please observe everybody. 30 minus 10, what is the value you're going to get it? 20. 20 is greater than or equal to, please observe, 20 is greater than or equal to, what is the value you're going to get it? 30 plus 10, what is the value you're going to get it? 40. 40 divided by 2, what you will going to get it? What you will going to get it, guys? 20. 20. Nothing but one condition satisfies. 20 is greater than or equal to 20. One condition satisfied. Nothing but what? From these values. Okay, from this value, the condition holds. Now take n value is equal to 40. Okay, definitely it works. Yes or not? Definitely it will works. 40 minus 10. Yes or not? So what you will going to get it? 30. Okay, again here also you can able to see what is that? 40 plus 10. Okay, divide by 2. 40 plus 10, 50. 50 divided by 2, what is the value? Okay, 25 you got it. Yes or not? What is the value you got it? 30. Here 25. Have you proved or not? You tell me, have you proved or not? Definitely we proved. That is the reason why we have to observe whether if this one is greater, growing is nothing but that time we have to go for fraction values. Okay, that time you have to check it, how to reduce this one, how to reduce this value, in what way I can able to reduce this value, in how what way this constant will going to help us to make this one bigger, make this one bigger. The constant, whatever the constant you will going to take, how this constant will going to help us to make this bigger, because I taken 1 by 2, c is equal to 1 by 2. Now you are getting this one bigger, nothing but hence we proved. Please understand, hence we proved saying that. Okay, n minus 1. See here, n minus 10. What is that? That is equal to omega of, what is that? N plus 10. That's it. I think it's a very good example. It takes a lot of time. Okay. Clear, everybody? Everyone clear? This one, this problem understood? Hello? Naresh, got it, Naresh? Naresh.
Yes, sir. Yes, sir.
Okay, so this problem is very, very important. So be careful. So I given a best problem, that is a really good one. Okay, so we will see one more, please. Maybe another two programs are there. We will finish and we will going to wind up. Okay, another two programs are there. We will finish and wind up. Okay, let's take example 4. Let's take example 4. Okay, now f of n, so that is equal to n square g of n, that is equal to n. I will going to write fastly. N square, we have to prove this one, big O of, this is what exactly we have to prove it. Okay, f of n is equal to g of n, c dot g of n, we have to prove which side this one is greater, like that we have to prove it. Now you check it, n square. Okay, understanding everyone, n square here greater than or equal to, okay, c dot n for all n, n is greater than or equal to n naught. Okay, how to prove this one? N square is greater. So what you will going to do? Please understand here. So before that, you can able to take, see for this one, everybody observe here, for this C, see here, observe here, for this C, you cannot take, for this example, I will going to take n into n, you will going to get n square, correct? N into n, you will going to get n square. Here also you can able to see C dot n. For that, whatever the n value you will going to take, you cannot take n value for C, because C is a constant value, right? You cannot take n value for this one because n is a function. Okay, you cannot take the constant for function. This is the constant value. Can you apply the function value to the constant? You cannot. Okay, this one you have to be very careful. Please understand, this one you should be very careful. So that is one reason. Because of this reason, we cannot able to prove always this is greater like that. That's why I cannot prove that n square is not equal to big O of n. That's what first program and last program I told you, right? That is what we have proved there. N square is not equal to big O of n. We cannot able to prove it. Again, one more, how to prove this one, sir? But see here, but if you take c value is equal to 1, if you take c value is equal to 1, and n naught, n value is equal to 1, definitely we can able to change this one. Why? Yes or not? So very simple. What we can able to do? N square, everybody, n square greater than or equal to c dot n. Okay, for all n is greater than or equal to n naught. Now substitute the values. 1 means 1. Yes or not? 1 square, nothing but 1, you will going to get it. C value also 1, 1 dot 1. Okay, for all n greater than or equal to n naught. Now is it proved or not? 1, okay, greater than or equal to 1, nothing but one condition satisfied. One condition satisfied or not, again you prove it. N value is equal to 2, you take it, no problem. 2 into 2, what is the value you will going to get it? 2 square, please understand, 2 square. Yes or not? 2 2s are 4. Okay, 2 into 2, 4, you will going to get it. Yes or not? So that's why 4 is greater than or equal to, see, observe here, 4 is greater than or equal to c value, what we have taken, constant value 1. 1 dot n value what? 2. What is the value you will going to get it? 4 greater than or equal to 2. Hence proved or not? This side we proved or not? This side we proved or not? Now you tell me, this side we proved or not? We proved. Perfectly we proved. So that is the reason why you have to understand where I can able to substitute the n value, constant value n as well as c. Then whatever the value will going to provide to c, that will going to make a difference. Which size you want to make a bigger, this will going to help you. That is the reason why constant is very, very important. Okay, constant is very, very important. Now I can write, I can say that, please understand, now I can say that n square is equal to omega of n. Okay, I cannot able to prove this, yes or not? I cannot able to prove this, but when I'm taking n value, okay, n value as well as c value is equal to 1, n value equal to 1 as well as c value equal to 1, automatically I can able to prove this one. What is that? N square is equal to omega of n. So this is what the things we did here. This is very, very important. Okay, so like that you have to understand what is the constant value we have to give. Okay, why we have to give. If I give that value, what happens? Everything we have to check it. Okay, please observe this one. Okay, be careful. Again, one more small program is small, one more is there. I think I'm doing more. Please bear me, don't feel bad. Just a moment, please bear, guys. Don't, I'm sorry. Okay, fine. Now you take last one, guys, last one. That's it, last one. I will take just 1 minute. Example 5. So that's why every day, please learn. Every day, please learn. You will get it. Okay, every day, please learn. Let's take a function f of n. Okay, that is equal to n. Again, g of n, that is equal to n square. Okay, please everybody, one thing you need to understand here, right side, if right side is greater, what is that? Big O. If left side is greater, what is that? Omega. If both are equal, that is theta. Okay, learn all these things, be careful. Okay, when you are learning algorithms is nothing but you have to learn this, you have to learn this. Okay, that's what. Okay, now see here, what is that? N is, I have to prove this one. What is that? N is greater than or equal to, directly I will write n is greater than or equal to c dot n square. Actually, what we have to prove? N is equal to omega of n square, we have to prove it. Yes or not? This one we have to prove it. Now I am taking these values. Now you check. Now you everybody observe here. What I am saying here, please, this one you please observe here. For all n, and n value is greater than or equal to n naught. Now you please observe these things. I wanted to make this one greater, but you see here, n is there. You see here, n square is there. Now you people tell me which is greater in this. Right side is greater. Yes or not? Right side is greater. Right side is greater. Okay, what you will going to do? For example, you people will going to do like this. N is greater than or equal to. Okay, what you will going to do? Some people will going to, sir, I will going to take c value as 1 by n. n you will going to substitute 2 or something like 1 by n dot n square. What happens here? You tell me what happens here. Here cancels or not? Okay, n is greater than or equal to n. Okay, so we cannot say that every time you will going to get a right left side greater like that. Okay, every time we cannot able to get left side greater, we cannot prove that here always this is greater like that. Okay, sometimes it may be a equal also. Yes or not? Sometimes it may be equal. So that is the reason why if it is equal, we have to write theta. Understood? When we have to write big O, when we have to write omega, when we have to write theta. See here not equal. Here basically n should be greater than or equal to n square we had here. Okay, but when I assume, when I take and c value is equal to 1 by n,